here that we see for parallelograms is that consecutive angles of a parallelogram are supplementary. Consecutive angles of a parallelogram are supplementary. Opposite angles are congruent. So first we have to think about what the term supplementary means. Supplementary means they add up to what? Supplementary adds up to 180. 180. All right, so consecutive, remember we looked at that term yesterday. They're side-by-side angles. They add up to 180 in all parallelograms. And then opposite angles mean corner to corner. Those are congruent. So that means they have the same measure. All right, they have the same measure. So consecutive add up to 180. Opposite are congruent. All right, the next one we're going to look at. If a parallelogram has one right angle, then it has 4 right angles, and it is a rectangle. So you cannot have a parallelogram with only one right angle. Why? Well, the one we just said. If opposite angles are congruent and you have one right angle, it means that the opposite is also a right angle. If consecutive or supplementary and you have 90 and then something that adds up to 180, the consecutive angle must also be 90, which means the other consecutive angle is also 90. So if you have one right angle in a parallelogram, it's a rectangle. All right, at least a rectangle. It could potentially be a square. All right. Opposite sides of a parallelogram are congruent. So opposite angles are congruent and opposite sides are also congruent. The diagonals of a parallelogram bisect each other. So we are bringing back the terms that we know. Bisect means what? Cuts it in half, right? It meets at the midpoint. All right, so they bisect each other. All right, so let's look at this parallelogram. If we know this is a parallelogram, we know that angle A is congruent to angle C. We know that angle B is congruent to angle D. We know that A and B are supplementary. They add up to 180. We know that B and C are supplementary. They also add up to 180. C and D are supplementary. D and A are supplementary. We also know that line segment AB is congruent to line segment DC, and line segment AD is congruent to line segment BC. All right? Diagonals then. Based on that last theorem, we know that line segment AO is congruent to OC, and we know that line segment DO is congruent to OB. All right? So as soon as we know it's a parallelogram, we know all of that information, which means that is true for any parallelogram. All right, so any parallelogram that we have, that's going to be true. All right, so that means starting with parallelogram, you have rectangles, rhombus, and square. Those characteristics would hold true for all of those. All right, those characteristics would hold true for all of those. So based on the flowchart that you have, all of those characteristics that we just did for parallelograms, parallelogram down, so follow the flowchart down, parallelogram, rectangle, rhombus, and square. All of these things would hold true for basic parallelograms. Basic parallelograms. All right? Those would all hold true for all of those. Your parallelogram, rectangle, rhombus, and square would have all of those characteristics. All right? So let's look at this first example here on page 257. Find each measure in the parallelogram ABCD if B to D is 11.6, angle ABC is 72, and then they want the rest of it. All right, so D to C. So we're going to look at D to C. That's the first thing they're asking for. D to C is this line segment right here. What do we know about parallelograms? Opposite sides are congruent. Opposite sides are congruent. Well, they gave us the measure of the opposite side, so we automatically know that this side is also 6.3 meters. All right, 6.3 meters. Look at the next one. EC. They want this right here. Well, we know that diagonals bisect each other, which means they cut it directly in half. So if this is 4.2, then we know that EC is also 4.2. All right, let's look at the next one, ED. All right, so E to D is right here. Well, in the information B to D, which is the whole length, is 11.6. Well, again, we know they bisect each other. That's the entire length, so we're going to cut that in half. So then we know this is 5.8. It's half of the entire length that it gave us. Let's look at the angles. All right. Angle DAB. DAB. All right. So the only angle measure they gave us was ABC, which is this one right here, 72. Now, I know that this angle A and this angle B are consecutive, meaning they add up to 180. So if I need to figure out what angle DAB is, I'm just going to take 180 minus the angle that they gave me, which is this one, 72. And so if I do that, then I know that my angle measure here is 108 degrees. All right. The next angle measure that it asks for is ADC. That is opposite of the angle they gave me. Opposite angles are congruent. I actually don't have to do any calculation here. That is automatically 72 degrees. 72 degrees. All right. All right, so let's look at the next one. DAC. DAC. All right, so for this one, this is a little bit different. All right, so they want this angle measure right here. They want DAC. All right, so this actually forms a triangle. All right, we have this part of the triangle, 63. We actually just calculated this guy. That guy is 72 because it's opposite. So how do I find my third one? What's a triangle? What do they all add up to? 180. So I could say 180 minus 72 plus 63, right? So 180 minus 135, 45 degrees. So I actually know that this guy is 45 degrees. All right. Find the measure of each angle and side in this parallelogram. All right, so in this case, they gave me a little bit of information here. We're going to start with the angles. Okay, we're going to start with the angles. We're going to say we know that these two angles are consecutive, right? So this angle and this angle are consecutive. So consecutive angles are supplementary. So I can solve for the angle measure by saying, well, 7A plus 13A should equal 180. And so I'm just going to solve, right? And I'm going to get that A equals 9. Now they specifically want the measure here, so I'm not actually done. I found out my variable, but I need to know my measure, so I'm going to plug it in. All right, so if I want to find out what angle J is, I'm going to say, well, angle J is 7 times A. So that's going to be 7 times 9. I'm going to get 63. You can solve for this other one two different ways. You can just plug it in. So angle M, I could say 13 times 9. Or we know that these are supplementary. You could say 180 minus 63. Either way, you're going to get 117 when you do that. Okay? So you can do it either way. Plug it in or just subtract because we know they are consecutive. All right, sides are actually a little more difficult here. I actually know that these two sides are congruent. So I know that x equals 2y plus 1. And I know that 2x equals 5y minus 2. But I have different variables in each equation, okay? And so you're going to have to go back to Algebra 1 and how we would have solved this, okay? So I have to look at one problem. So let's look at this one. He's actually the more difficult one. We have a 2x there. How do I solve it? Well, I need just one variable, okay? I need to get that to one variable. And so I'm actually going to use the other statement that I know to be true. So I know that x right here equals 2y plus 1. So I'm actually going to use the method of substitution here. So in this particular equation, I'm going to substitute in this group for my x, all right? I'm going to substitute in that group for my x so that I get it to one variable. So I'm going to rewrite this equation here I'm going to rewrite this equation, and I'm going to substitute in the x what I know it's going to be. So I'm going to take it and I'm going to say 2, and instead of x, I'm going to write what I know x equals for my first equation. So 2y plus 1, substitution. We did this in Algebra 1. All right? So instead of 2x, I'm going to write what x equals, 2y plus 1. And that is going to equal the 5y minus 2. And now I have an equation with only one variable, right? I don't have an x and a y, I just have a y. So how do I solve this one? What do I do first? How do I simplify the left side? Yeah, I'm going to distribute. I'm going to distribute my 2's. So I have 4y plus 2 equals 5y minus 2. I need variables on one side and numbers on the other. Subtract my 4y over, right? Subtract my 4y. On the left-hand side, it cancels. I get 2. On the right-hand side, 5 minus 4 is just 1y minus 2. I'm going to add over. So now I know that y equals 4. I know my y value. That's really all I need to give the sides. Honestly, you can solve for x if you want to, but you don't have to because these sides are congruent. I can go back up here and plug in my 4. 2 times 4 plus 1. This side is going to equal 9. And this other side up here is also going to equal 9. They're congruent. I can plug in a 4 right here. 5 times 4 is 20, minus 2 is 18. I don't even need x. I know that that equals 18. If they wanted me to solve for x, I can solve then. 2x equals 18, x must be 9, right? But your sides are congruent, so you don't even have to go back and find x if you don't want to. First of all, this is a parallelogram. We know that from right here. All right, that's the symbol for the parallelogram. This is a parallelogram. We'll start with A. So they want us to find the measure of E in A. That's this guy right here. You actually don't have to do any calculating, but you do have to recall some terms that we learned. If this is a parallelogram, that means NE is parallel to TA. And that means this guy right here, NA, is a transversal, which means that this angle and this angle are alternate interior angles, which means they're congruent. So there is no calculation that you have to do to find him. He is going to be the 36. They are alternate interior angles. So 36 is the measure. You didn't have to do any calculations there. You just had to remember parallel lines and transversals and what's created with the transversal. All right, let's look at B for this one. The measure of angle T. Well, angle T and angle E are opposite, which means they're congruent. So if angle E is X, then so is angle T. And then I have this little triangle that's made here, NTA, this triangle. Well, triangles always add up to 180. So that means X minus 2, this angle, plus my X, because it is congruent there, X, plus the 36 should equal 180. So I add my X's, 2X, my negative 2 and 36, 34. Subtract 146, divide by 2, X is 73. Well, if X is 73, that means angle T is 73, which is how I got this one. Let's look at 22. 22, the measure of each length, NE. Well, NE is congruent to TA. Congruent means they equal each other. So I set 5y equal to 3y plus 8. Subtract my 3y. 2y equals 8. Divide by 2, I get y equals 4. They want the measure. So I need to plug it back in. NE is 5y. 5 times 4, 20. NE is 20. Then they wanted TN. TN. Well, TN should be congruent to EA or AE. I already know what y is. Y is 4. So 4 times 4 minus 4, that's 16 minus 4, or 12. Since these two are congruent, that means TN is also 12. All right, section 6.3. This is all parallel. This is all proofs here. Our theorems. We're not going to actually do the proofs, but we are going to go through the theorems. These are basically the converses of what we just said. So I just want to go through the converses and then we'll go through this chart. Quadrilateral is a parallelogram if both pairs of opposite sides are congruent. Well, we just found out that if it's a parallelogram, both opposite sides are congruent. So if the opposite sides are congruent, then it's a parallelogram. It's just the converse. The quadrilateral is a parallelogram if one pair of opposite sides are congruent and also parallel. So if you can prove they're parallel and congruent, you only have to do it with one set. If you can only prove congruence, you have to do it with both sets. All right, but if you can prove that it's parallel and congruent, then just one set will prove it, the other two will follow. Quadrilateral is a parallelogram if both pairs of opposite angles are congruent. All right, so again, the converse. In the first section, it said if it's a parallelogram, opposite angles are congruent. This is just the converse. If opposite angles are congruent, it's a parallelogram. And a quadrilateral is a parallelogram if the diagonals bisect each other. Again, converse. We said if it's a parallelogram, they bisect. If they bisect, it's a parallelogram. These are just the converses. All right? So on your handout, this is the flow chart. I'm going to zoom in on each type so that you have what you need here. All right, so we're going to start all the way in the far left. A kite, it is its own thing. It does not have a grouping. It is a quadrilateral, but it's not a parallelogram. Two pairs of consecutive sides are congruent. It has two pairs of consecutive congruent sides. We haven't actually gotten into this particular in our book, but we're going to go ahead and talk about this characteristic and fill this in so as we go we have it. For a kite, diagonals are perpendicular. You'll notice that it doesn't say they bisect each other. Diagonals are perpendicular in a kite. Exactly one pair of opposite congruent angles. No parallel sides. No parallel sides in a kite. No parallel sides. All right, so let's look at the trapezoid all the way over to the right-hand side. A trapezoid has exactly one pair of parallel sides. Exactly one pair of parallel sides. Which means by that question that we just got, they can't be congruent. If they were congruent, the other side is going to be parallel as well. All right, so the bases that are parallel are never congruent. They're never congruent. If they were parallel and congruent, we would have a parallelogram. All right, so exactly one pair of parallel sides. And then to be a little more specific, the isosceles trapezoid. It's a trapezoid, so I mean it has the characteristics of what is above it, one pair of parallel sides, but it also has a couple more things. The legs, which are the non-parallel sides, the legs are congruent. All right? Base angles are also congruent. So that means base angles are also congruent for this guy. And actually, all your base angles are congruent here. All right? Base angles are congruent. Diagonals for a isosceles trapezoid only are congruent. All right? And we have other ones that are congruent, but as far as trapezoids go, if it is an isosceles trapezoid, your diagonals are congruent. Congruent, meaning they're the same length. They are the same length. All right. So let's first look at quadrilateral. 4 sides. That's true for every single thing on this flow chart. Specifically, we have parallelograms first. 2 pairs of parallel sides. And then we have a list of things here. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. Diagonals bisect each other. Down the parallelograms. All right. We have rectangles and rhombus. These are going to have all the characteristics of your parallelogram. All right, so it's going to meet all of those requirements of the parallelogram as well. You are going to have diagonals that bisect each other. You're going to have 2 pairs of parallel sides. You're going to have congruent opposite angles and supplementary consecutive angles. So everything that was a characteristic for the parallelogram is also a characteristic for the rectangle and the rhombus. But you have a little added features. For the rectangle specifically, you have 4 right angles. Along with bisecting each other, the diagonal for a rectangle, those are congruent. So not only do they bisect each other, they are also congruent, okay? So the rectangle's diagonals take the characteristic from the parallelogram, they bisect each other, and they are also congruent, meaning each piece of the bisected diagonals are all congruent. For a rhombus, it does not have the 4 right angles. It has 4 congruent sides. It has all the characteristics of the parallelogram as well. The diagonals do bisect each other. However, the diagonals are also perpendicular. So not only do they bisect each other, they are perpendicular bisectors of each other. Okay, so they bisect at right angles. The diagonals also bisect the angles themselves. So that means that the diagonal across here is going to bisect this angle, and it's going to bisect that angle. These angles are congruent because it's a parallelogram, and they're going to be bisected by the diagonal. The diagonal here is going to bisect these angles, okay? So diagonals are congruent, they bisect each other, and they also bisect the angles that they go from vertex to vertex, okay? So it keeps all the characteristics of the parallelogram. It picks up these extra ones. And then the last one we have is the square. Now the square is kind of a combination of the rectangle and the rhombus. So 4 right angles and 4 congruent sides, which means the square has all the characteristics of the parallelogram, the rectangle, and the rhombus, okay? So that means for the square, the diagonals are going to be bisecting each other. The diagonals are going to be congruent. The diagonals are going to be perpendicular. And the diagonals are going to bisect the angles. So diagonals are going to create 45-degree angles. okay? It meets all the characteristics of everything above it. Instructions, the first set of instructions said this is a parallelogram. What is the value? This says what value would you have to have for it to be a parallelogram? The process is the same. In order for 8 to be a parallelogram, the sides must be congruent. Opposite sides must be congruent. So the process is the same. You're going to set them equal and say this must be the value I'm looking for. All right? For 10, well, if this is a parallelogram, I know that they bisect each other. So that means the pieces of my diagonal must be congruent in order for this to be a parallelogram. So it can word it two different ways. It can say this is a parallelogram, find the value, or it can say what is the value in order for this to be a parallelogram. It can ask it two different ways and the process is the same. So go ahead and solve these two.